How does radiative forcing affect Earth's temperature? Imagine Earth's climate as a delicate balance of energy. Every day, the sun sends energy toward our planet, and Earth sends some of that energy back into space. Radiative forcing is the term scientists use to describe how this balance shifts. When more energy comes in than goes out, Earth warms up. When more energy leaves than arrives, Earth cools down. This balance is what keeps our climate stable or causes it to change over time. Earth receives solar radiation from the sun. Some of the sunlight bounces off clouds, ice, and particles in the atmosphere, while the rest is absorbed by the land, oceans, and atmosphere. After absorbing this energy, Earth emits heat in the form of infrared radiation back into space. Radiative forcing measures how different factors change this energy flow. For example, greenhouse gases like carbon dioxide trap more infrared radiation, preventing heat from escaping. This causes positive radiative forcing, which leads to warming. On the other hand, some things cause negative radiative forcing. Volcanic aerosols can reflected sunlight away, and increased surface reflectivity, called albedo, can also cool the planet. But human activities in recent years have mostly increased positive radiative forcing. Burning fossil fuels releases greenhouse gases that trap more heat, raising Earth's average temperature. Climate models use radiative forcing as a key input. They simulate how changes in greenhouse gases, aerosols, solar output, and land use affect Earth's temperature over time. These models help scientists predict future climate scenarios and understand how different factors influence global warming. They show that higher levels of greenhouse gases increase positive radiative forcing, which leads to more warming. The amount of radiative forcing is measured in watts per square meter. This tells us how much extra energy is entering or leaving a specific area of Earth's surface. For example, a radiative forcing of 2 watts per square meter means 2 joules of energy are added or removed each second for every square meter. Understanding radiative forcing helps us see why Earth's climate is changing. When greenhouse gases increase, they cause positive radiative forcing, trapping more heat and warming the planet. When aerosols or other factors cause negative forcing, they can temporarily cool the surface. Recognizing these effects allows scientists to better predict future climate change and develop strategies for sustainability. In essence, radiative forcing is like a thermostat for Earth's climate. When it tips toward positive, the planet warms. When it shifts negative, it cools. This simple idea is at the heart of understanding global climate change and how human actions are influencing our environment.